Hello humans, I'm Inflatable Robot, and in this video I've got a Rock-Tech chorus pedal. It's a kind of plasticky, cheap chorus pedal from the 80s, and it purportedly does not power on. So let's check that real quick, make sure that that is true. This will not be a very interesting video if it does work. So, plug it in. I am getting no red light here. So that seems like that was, you know what? The battery compartment's right here. Isn't that neat? Right out here on the front. We can check if the battery input turns on. Ooh, look at that. Look at that. Let me zoom in real quick. Look at that. Ooh. We got some electrical tape and a jack that's falling apart. So let's go ahead and plug this in real quick. And once again, we have no power, or at least no LED light. So I'm gonna unplug this again, put this back. Let's open it up and take a look on the inside. See what we can see. Now with the power cable, or the battery power, being in the condition that it's in, I'm suspecting a couple different things right off the bat. One, that it's a power issue, obviously, and I imagine the circuit actually works if it could get power. But two, and maybe the thing, is that the circuit stopped working and someone tried to fix it and was unsuccessful. So the battery cable was not actually the culprit. They replaced it and were unsuccessful in their pursuits. All right. So right off the bat, I can see that we have some funky business going on at the power input section right here. Let me zoom in a bit so you can see what I'm seeing. All right. So you see what's going on here. We've got some like frayed wire right here and here, and I imagine that's that battery cable. Not the best soldering job there. Let's see. Oh, that comes right out. Very nice. Very nice. Oh, yeah. That's neat. Yeah, I can see right here that we have some really questionable soldering for that battery cable going in here. And I imagine we have some bad connections here. Get out my multimeter and see if we have any continuity. Here we go. Let's set that to voltage DC. Actually, let's set that to continuity. We'll set it to beep. Beep, beep. All right, let me just plug in my battery connector for the power, and we can test our continuity. So let's see here. I'll just hold that there. Okay, so that's the positive input. That is not beeping there. It is beeping there. That's nice. Okay, so let's test our negative side. If I can hold that. That's there. Not there. Ground seems to be good. Yeah, okay. So that's funny because I'm getting continuity through the power jack. So now I'm thinking that there is a problem in the circuit, and this attempt at fixing was not actually addressing the issue. But I think we could probably go through here fix up this soldering right around here and replace this battery terminal with one of these right here, and then we can reassess. So I'm going to do that. First of all, let's get this battery cable. I'm just going to cut that out. Get this guy right here. There. That is free from its confinement. A little bit of braid there. I like to dip my braid into a bit of flux in order to get the board extra nasty. It does really help to get the solder up off of the joint though. Ugh. There we go. Don't breathe that stuff in. Let me zoom in a little bit so you can see what we got going on here. So, this side of the cable came right out. I didn't have to do anything. This one I cleaned up the jack a little bit. I might need to do it some more. And then the positive. I can. Cool. Let's see if I can solder these in. Okay, let's see if we have continuity now. Let's go positive. Yep. That's good. And then this goes down over here to here. Yeah. All right. Now with our negative. That is switching. And that connects all the way around. But if we plug in a jack, it should disconnect. Right. All right. Let's give it a quick test to see if that amount of soldering was enough to bring it back to life. Let's give it a button. And no red light. So we have some further issues to resolve. I don't see anything that's immediately apparent. As far as the capacitors go, it's time to start diving deeper. Maybe look at the schematics. All right, it took a short break to print out the schematics for this, and our battery light is still not coming on. But it seems that we have power now. And I can tell this because I've got this fun little oscilloscope here. This thing's super cheap. It only costs like, I don't know, 30 bucks, I want to say. So now we can see that we have power coming in. We can see that line jumping up. It's going there. It's going there. Followed around to here. It's working there. I got power going all throughout this guy. At least to where power's supposed to go. Now let's see if there's life in the circuit. So according to this, the depth pot right here, that's what this is. This is the knob for the depth. Gets attached to the LFO that generates the control signal for the bucket brigade. It wobbles the control voltage up and down. So we should be able to touch this pin right here. And in fact, we do see that control voltage going up and down. So the circuit has life. It's working ostensibly. what I can tell now is that the switching circuit is not working. So my first suspect is this switch itself. So that's this big piece right here. I can see that 9 volts, or not, 7.6 volts as it were, is going in on this bit. And I think this is the other sides of the switches. Now, if I hold it on here and I actuate the switch, I can see that the voltage is going through. It's going through to here. Yep. That crosses over to here. And we're getting voltage throughout this part. So here's this foot switch. The foot switch is taking positive voltage and sending it over to this 4027. That's this chip right here. This is a CMOS. It's like a flip-flop, so it just switches between high and low. And we can see that that input signal comes in on pin 3, which is right here. And that is low. And it's not going high when I hit the switch. That's not going high. So let's see here. Pin 6 and pin 5 both go to positive voltage. I wonder if I directly bridge pin 5 to pin 3, will this light come on? Let's see here. Pin 3 and pin 5. Oh, did I see it? Am I fooling myself? Ah, there it is. The light has come on. So, this CMOS, this bit right here, is working. We've got life. What that tells me is something's going on in between this switch right here and this pin, because I can directly bridge pin 5, which is positive voltage, to pin 3, and that activates it and turns the light on. So something's going on right here. I wonder if one of these traces is broken. Well, I think it's time to take a look at the board. Okay, so here is the switch right here. That's bringing power over to here. We've tested that. That works fine. That has a component that bridges over to this cluster right here. This voltage is fine, and oh, look at that. I can see a little damage on the board. We can see, like, right here, there's a little pitting. Right here, there's some scratching. Right here, there's a little spot right there. That's right in a trace. I wonder. Put my electric meter in beep mode. Beep, beep. So let's see here. This pin right here and this pin, those should be touching. What about this pin and that pin touches? Does this one touch this one? Okay, so these two right here should be beeping. So I can tell that that line right there is broken. So I think from here what we could do is we could take this pin and bridge it over to here. And that should repair that trace. We'd be going around the back way there. I think that'd be a good way to go about doing that. I'm just going to take the leg of a old resistor and I'm going to bridge a couple of points here. This point and this point right here should be connected through this trace. So if I connect these two with a jumper, I should be able to restore functionality. Okay, let's tack this one right here. Like so. Cool. Let's add a little bit of flux here. Not flux, a little bit of solder right there just to tin it. Now let's bend this down. Alright, so now I have put that little patch wire in. let's beep it out to see if it is working as we expected. So this point should connect to this point, and it does not. It does. Okay, good. All right. So now let's see if we can get that switch to come on. Jumbled up here. Plug that in, and now, all right. That seems like a success. Let me put this together and let's test it out. I think that probably constitutes a win. Very gingerly put this back together because it's kind of cheapy plastic. All right. And then we have the plastic back plate. And then the metal back plate. Yep, it's still coming on. That's a real nice sign. Now let's see how it sounds. All right, well, I think that concludes this video. We managed to get this up and working with just a simple little patch. Just had a little bit of a break in a trace, but unfortunately, it was a really important trace. So once we managed to get that fixed by just bypassing it with a quick little jump, then it worked fine. All right, I'll see you guys next time.